Hi guys, today we're doing scientific notation. So your homework tonight is page 219, 1 through 41 odd. On Monday we will have a quiz 5.1 through 5.4. I will post it on Monday. It will be due by Tuesday at 8 a.m. All right, let's get started. So here we go. I'm going to skip the warm-up for here. This is definitely the kind of material that would be on your quiz, though, for sure. So if you want to go back, pause it before I show the answer. Okay, here we go. Scientific notation is what we use to write really big numbers or really small numbers, meaning distance from here to the moon, the size of an atom, a molecule. So here's how it works. We take a number between 1 and 10. It can be equal to 1, but it is less than 10. It cannot be 10. And that's what A is, okay? This number right here is a number between 1 and 10. It could be greater than 1, it could equal 1, but it has to be less than 10. So it could be 9.99, but it can't be 10. It could be 1, can't be less than 1. So between 1 and 9.999999999, okay? That's what A is. Any number between 1 but less than 10. And we multiply it by 10 to a power, okay? By 10 to a power. So here we go. And B has to be an integer. This means B is an element of the integers, so it has to be an integer. So there's no fractions here. Okay? Now, so what we would do is we look for where the decimal point naturally is, and that would be naturally to the right, right here. Any number naturally has it to the right. And then we're going to move it. We have to make this number become a number between 1 and 10. Okay? So where would I move that number to make it a number between 1 and 10? I move the decimal between the 3 and the 7. So then what I have to do is count the number of places, not commas, but zeros or digits. So I'm going to count 1, 2, 3, and we end up going over 12 times. Okay, so then we write that number that we see, which is just right here, 3.78 with the new decimal, 3.78. Now, if there were more digits that went out here, 9, 10, 5, I would go as long as I saw my digits until I hit the zeros. I don't need to write the zeros. Times 10, and the power is going to be the number of jumps. Okay? Now, this time on the decimal, now remember, decimals are fractions. And how do I show fractions with exponents? I show them with negative exponents. So we're going to do the same thing. I have to move it 1, 2, 3, 4, 5, 6. That's not between 1 and 10 if the decimal goes there. I have to go 7 times. 6 4/10 times 10. I'm going to count. I did 7 jumps. 10 to the, how do we show a decimal? We show it with a negative exponent. Okay? So again, I'm moving 7 jumps. 6 4/10 times 10 to the negative 7. So if it starts out as a decimal, we should see it shown as a negative exponent. If it starts out as a whole number, it should be a positive exponent. All right, so let's try it. Pause the recording. Let's see what you... All right, let's check number 1. My decimal is naturally to the right here. I have to move it once, twice, 3 times, 4 times, 5 times, 6 times. I have to go one more, 7 times. So this becomes 4.6 times 10. It's a whole number. So to the 7th power. 1, 2, 3, 4, 5, 6, 7. Yep. Pause the recording. Try the next one on your own. Okay. So let's check it. The decimal should go between the 6 and the 2, and it's jumping 3, 6, 9, 10, 11. Right? So it's 6 and 2/10 times 10 to the 11th power. Okay, small numbers. When we're talking about decimals, remember, we're really dealing with fractions. Decimals are fractions, and fractions are shown with negative exponents. So all decimals should be shown with a negative exponent. So where do we move the decimal so it becomes a number between 1 and 10? It goes between the 5 and the 3. Gonna jump it 1, 2, 3, 4. And I don't get to cut off the 8. As many digits as there are is what I have to write to keep it a number between 1 and 10, but less than 10. So this would be 5.38 times 10 to the negative 4th power. Okay, pause the recording and try the next one on your own. All right, let's check it. I'm moving it over. Now remember, it has to be a number between 1 and 10. So when I jump 1, 2, 3, 4, 5, I don't stop there because that would be 0.4. 0.4 is less than 1. It has to go over here. Remember, it's a number between 6. So I'm moving it 6 times, right? And so it's 4 times 10 to the negative 6th power. All right, take a minute and try these on your own. Now let's check our work. Now this is what we call, we're given the information in standard notation and we have to convert it to scientific notation. Notation means writing. So scientific writing, writing is when we're multiplying by a power of 10, and standard notation is how we're normally used to seeing it. So let's check our answers. 6.3 times 10 to the 4th. Now notice this has a lot of decimals, number 2. A lot of digits. So I'm moving my decimal between the 7 and the 2, but I still have to write 2, 4, 5. The only things I get to drop off are the zeros. So it's 7.245 times 10 to the 6th. Okay, number 3, I'm moving it over 3, 6, 9, 10. Right? There's my decimal naturally, is always on the right if it's not written. And it's going to be 5 times 10 to the 10th. Let's look at number 4. This one's a smaller number, so I'm moving it between the 8 and the 7. It would be 8 and 7/10 times 10 to the 1, 2, 3, 4 times 10 to the negative 4th power. Okay, let's look at the next. Remember, we're going to need 6 and 53/100 times 10 to the 1, 2, 3, 4, 5 to the negative 5th power. Now, the one thing to remember on this last one is that you make sure that that decimal goes to the right of it, so it's a number between 1 and 10. And then it'll be 2 times 10 to the negative 7th power. Okay, so now we are going to, we're going from scientific notation to standard form or standard notation. So here we go. I'm going to start with the number, okay? Now, if it's a whole number, you're going to move to the place where you're going to make it a whole number. The direction I move to make it a whole number, my decimal would have to go that way, to the right. And I'm going to move it once, twice, 3 times, 4 times, 5 times. in all those separate areas, I add zeros. Okay? Let's go here and put the arrow that way. Okay? And now I moved my decimal over here, so now I have 1, 2, 3, 4, 6, and 3, and I'm going to place my commas. Okay, let's try it again. Starting at 8 and 43 hundredths. Now notice it's a negative exponent, so it has to... I'm not sure where the recording stopped, but I'll try one more example. So let me go back. Oh, sorry, guys. All of a sudden I noticed it was hit on pause. So if I am going from standard form to standard form from scientific notation to standard form, I take the digit 3 6/10, and to make it, notice it's 5 to a whole number, so I'm going to move it 5 places to the right. 1, 2, 3, 4, 5. And then I rewrite the number with the commas. Okay, we start with 8 and 43. Since it's a negative exponent, we know that it has to move to the left. And I'm going to move it 7 places. Because it's a negative exponent, it's a fractional amount. To keep it a fractional amount, I have to keep it a decimal, move it to the left. 7 places. Okay? And then I always have to write a lead 0. We can never start our decimals without at least, we need something in that ones place. But it's 7 places that the decimal moves. All right, so you guys pause the recording and try the next few. Here we go. Okay, so we're going to start with 2 and 64 hundredths, and I'm going to move 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Add the decimal. Now I'm going to, every 3 places, I'm going to add my commas. Okay, let's start with number 4. I'm going to start with 3 and 41 hundredths. Because it's a negative exponent, I move to the left to keep it a decimal. And I'm going to move over 6 places. 1, 2, 3, 4, 5, 6. Add the decimal and the lead 0. I'm going to check our answers for the next 2. Okay. Don't worry about the scientific calculator, but when you get something that looks like this, this is what it means, okay? Okay, so anyways, we're going to do this without the scientific calculator. So we're multiplying 2 times 8 is 16, and then we can count. This is pretty easy because you can, when you have all these zeros, we can just multiply 2 times 8. That's 16, and how many zeros is that? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I can now make that 1 6/10 times 10 to the 3, 6, and 3, 6, oh, it's 8. 5, 6, 7. 7 zeros, but 8 digits, right? Times 10 to the 8th. Let's see what they're writing here, if I can do this with you guys. Yep. So they're just writing this in scientific notation. If you have a scientific calculator, you can use it. All right, let's talk about multiplying with scientific notation. When we multiply with scientific notation, okay, it's similar to our rules with common bases. Think of your 2.1 and 1.5 like they are. Think of them like they are what we're doing with our rules of exponents. We multiply those numbers by normally, since all this really means multiplication, but we're going to multiply 2 and 1/10 and 1 and 5/10 together, and we'll multiply common bases of 10 together. So we'll rearrange it. Okay, 10 to the 8th times 10 to the 6th. Now here, we're multiplying by normal, just good old-fashioned multiplication. 2 and 1/10 times 1 and 5/10, it's 5, it's 10, I'm going to add a 0, it's 21, it's 5, 1, 3, and notice I count my decimal digits, 1 decimal digit, 2, so I move over once, twice, it's 3 and 15/100 times 10 to the 8 plus 6. Okay? So that ends up being 3 and 15/100, and then we're using our rules of exponents here, times 10 to the 14th place. Let's see how good my, there we go. Now the one thing you have to make sure of is that this number right here is in scientific notation. If it's not, you're going to have to make it smaller or bigger, and I'll show you how to do that on the next one. So now we're going to multiply 5 and 63/100 times 3 and 4/10, and 10 to the 7th times 10 to the 8th. 10 to the 7th times 10 to the 8th, we add the exponents, right? So it's 10 to the 15th. Now, you will notice this looks like it's in scientific notation, but remember this rule? It's a number between 1 and 10. Is this a number between 1 and 10? No, it's not. So we have to manipulate this. So how do I change that to become a number between 1 and 10? I have to make it smaller and move this over by 1, right? I have to make it smaller by 1 and move the decimal over one place. Okay, so if this number gets smaller, then my exponent gets bigger. If this number right here, if this small number gets smaller, then exponent gets bigger. If this number gets bigger, then this gets smaller. You have to keep it in balance. So as one gets bigger, the other gets smaller. So we are moving and making this from 19 to 1.9. Since this gets smaller by 1 digit, this has to get bigger by 1 digit. So it becomes 1.9142 times 10 to the 16th power. Now notice I didn't cut off any of those digits. Okay? Okay, let's try it again. Now your turn. So 8 times 1.2, 10 to the 14th times 10 to the 11th is 9.6 times 10 to the 25th. Remember, we're multiplying 8 times 1.2, 10 to the 14th times 10 to the 11th. Okay, let's try the next one. Now notice, is this in scientific notation? No. It's got to be made smaller by 1 decimal. Move the decimal over one place. So 10 to the 16th becomes 10 to the 17th because that has to get bigger. Okay, pause the recording and try the next two on your own. Okay, let's go. When we multiply, we have to make, this is not in scientific notation, so I'm going to make it move it over smaller by 1, so it's 2 and 405 thousandths times 10 to, I have to make it bigger. I can't delete that 0 because it's in between two digits, so it would make that to the 19th power. Okay, here we go. Now remember, when we're doing 9, when I'm doing, remember, I'm just using my rule, 10 to the negative 6 times 10 to the negative 5. That makes, remember we add the exponents, negative 6 plus negative 5. That makes 10 to the negative 11th. Okay? Now, don't worry about those negatives. Same thing, we're just adding our exponents. But when I get this, you see that it is not in, it's not in scientific notation. So again, if this gets smaller, 83 and 4200ths, if this gets smaller, this exponent has to get bigger. So I'm moving it one place, so it becomes 8 and 342 thousandths times 10. Bigger means it actually goes to the negative 10th power. Remember, bigger in the negative numbers would be to the negative 10th power. Okay? All right, same thing with dividing. Okay? Only this time, remember, when we have x to the 10th over x to the 7th, we're really just subtracting the 10th power minus the 7th power, the top minus the bottom. Okay? So we're dividing these like normal and we're subtracting these exponents. Okay, so let's show you. Let's see. 3.5 divides into 9 1/10. I'll do the division for you. So let's remember 3.5 into, top dog goes in the dog house. So I have to move this over, I have to move it over, bring it up. Multiply by 10, bring it up. Okay, so 35 goes 2 times. That's 70. I have 1, I have 2. I'm going to bring down another 0. And it goes 3 times. So 9 1/10. Oh, wait a second. Sorry, it's not 3 times. So 35 times it goes into 310. Let's see. Six times. Okay. So 6 is 30, carry the 3, it's 210. So 9 1/10 divided by 3 5/10 is 2 6/10 times 10 to the 12th power minus the 7th power. So 2 6/10 times 10 to the 5th power. Let's look at how that looks here. Okay, let's try another. Divide. Now, I would say it's okay if you're hand dividing 5 74 thousandths by 5 9/10 with a calculator, but you've got to know what to do with that. Okay, now we're not in scientific notation, so when we're left with, it's what you do in the end. Notice this is not a number between 1 and 10, 86 thousandths. So we actually this time have to make it bigger. So if I make it bigger by 1 decimal, then my exponent gets smaller by 1. Okay? Let's try 2 more. Pause the recording. Now let's check our work. Okay. Let's check our work on the next one. We have to make it, it's not in scientific notation, so I move it over by 1. It's become 6.9, and this becomes 10 to the 11th. Make it smaller. Okay, we're going to stop there. We're not going to add right now, okay? That is our lesson for the day.